Okay, so this lesson is 4-4 compositions of transformations, but we're actually starting the lesson here where we're going to go over rotations from yesterday. So I had you write down the coordinates, and these numbers are just the coordinates from the shape that's on there. I don't know if you realize that. But I just had you write down the coordinates that correspond with the shape. We're going to just practice doing rotations. We did rotations yesterday. Today we're just going to practice it a few times, and then we'll bring it into the lesson for today. So starting with number 1, it says rotation 90 degrees. And so what you would need to do is actually look for the rotation rule, and I have them up on the board. So 90 degrees, the rule is negative yx, and we're just going to write that on our paper. Negative yx, like that. Okay, so a 90 degree rotation, that's just like one turn this way, so our shape's going to end up here. We're just going to use this rule to transform our points. So for example, J would then be positive 2, negative 1. So I'm just taking the y, changing the sign, and then putting the x in this position. And then K here, just like that. And then V, and we get these numbers. Then once you transform your points, then just graph the shape. So this is J prime, K prime, and B prime. And then here's your new shape after the rotation. Okay, next. Now we're going to repeat this with rotation of 180 degrees. Just looking at our rotation rules, 180 degrees, the rule is negative x, negative y. So something to just take note of is there's no chart like this on the reference sheet with all the rotation rules and reflection rules. So as you're going about them, try to memorize them as you're doing it, so that way you can remember it if it's on the standardized testing, whether it's the exam or FSA as well. Okay, so we wrote down the rule, we have our points written down, now we just need to transform them based on the rule. So we get negative 1, 1, negative 4, 3. So as you can see, I'm just changing it to the opposite sign. And 0 just stays 0. It doesn't go negative. No such thing as negative 0. And then once we have these new points, we can graph them. Okay, so it was 180 degree rotation, so 2 turns on the graph, so it makes sense that it would land right here. Another way you can check yourself is just take the corresponding points, maybe it's J, and if you draw a line through the center of rotation, it should make a 180 degree angle, which it does, so we're good. And continuing, now we do have a 270 degree rotation. Taking the rule off the board, it is y, negative x, and then transforming the points. And then we can graph it. So okay, so there's a new shape. Just, of course, make sure it's logical. It's 270 degree turn, so it makes sense that it turns 3 turns, lands in that quadrant. And moving on. The next one says a rotation of negative 90 degrees. Now, if you look up at our chart, we actually don't really have a negative 90 degrees on there. And the reason being is because negative 90 is the same as 270, so we just use that rule. So if you had a point right here and you were rotating it 270 degrees, it would land maybe right here. But also, if you rotated that point negative 90 degrees, it would land in the same spot. So therefore, we don't really write out a rule for negative 90. We just go with 270. So our rule here is y negative x again. And then just write down your new points. And then we graph. See. Okay, so now we're going to go back to that first page and just fill in the first page. So just flip to 4-4, composition of transformations. What we're doing here, composition means we're putting more than one transformation together. So we're either doing like a translation then a reflection or a translation then rotation. We're just doing more than one step. So composition of transformations is when two or more transformations are applied to a figure. The composition of two or more, and this is a new word, isometries. Isometries is also an isometry. What that word means is like when you change the location of the shape isn't changing itself, like all the dimensions, all the angles, everything's the same. It's just changing location, so that's an isometry. The pre-image is congruent to the image, so all the dimensions are still the same. And then one example of composition of transformation is a glide reflection. In a glide reflection, you're like sliding the shape, then reflecting it over a line. So it's a translation followed by a reflection. The translation vector and the line of reflection are parallel. We'll see that here in a second. Okay, so now we're going to practice doing a composition of transformations where there's more than one transformation happening. First, it gives us a triangle, and it gives us the coordinates of the triangle. It says graph ABC and its image after translation along -5, 3, and a reflection on the x-axis. So we're going to do the translation first, then the reflection, and it's important that you do it in the order that it states. So first things first, though, we do need to graph our points, so we'll just graph these 3 points. A is at 3, 3. B is at 4, -2. And C is at -1, -3. Okay, that's our original. Now we're going to do the translation, which is -5, 3. So we have to go to the left 5, up 3. So from each point, I'm going to the left 5, 1, 2, 3, 4, 5, up 3. Get A prime. Oh, up 3, I've read that part, B prime. And C prime. Okay. So we did the translation, and then next step is to do the reflection over the x-axis. So just identify the axis you're doing the reflection over. And then Now I'm going to reflect the points over. Now C will just stay in the same spot, so C double prime is just same spot. B would be 1 point this way, so double prime's right there, and A is 6 units up, so we have to put it 6 units down. So A double prime's right here, and then you can connect your dots. So this shape is actually the answer. It's the final image. So for some of you, graphing will work better, especially if you forget like rules, like all of that. You could always graph it and find the image. Another way to do it is to use the points and the rules of the points. So that's what we're going to do over here. I'm going to try to match the colors as best I can. ABC right here, I'm going to put the original points right here for ABC. So I'll have 3, 3, and I'm just taking this from the problem 4, -2, and then -1, -3. Now what? Now I'm performing the translation, and the translation vector is -5, 3. So from here, I can add this to the coordinates. So 3 plus -5 is -2, 3 plus 3 is 6. And I get these, and just make sure that that's what I have graphed. So -6, 0, yeah, that's C prime, -1, 1, B prime, and -2, 6, yep, A prime. Next. Now for this, a reflection on the x-axis, as far as the points go, I'm going to look for the rule. X, -y is the rule, and I'm just looking right here. X-axis, xy equals x, -y. Another way to consider that is when you reflect on the x-axis, x stays the same, y changes sign. That can help you remember what you're actually doing. So x stays the same, y changes sign. X stays the same, y changes sign. We get this. And of course, just make sure that it's logical. It's what you have graphed already. Okay, next page. Now we're going back to the page from before. Let's practice another one together, and then I'll let you practice it on your own. Or if you're at the point where you want to practice it on your own already, more power to you. Okay, so here we have our original. It says 90-degree rotation and reflection on the x-axis. So 90-degree rotation, the rule for that is -yx, and then reflection on the x-axis will be x stays the same, y changes sign. I need to get the points off the graph for J, Z, and L. J is at 1, 2, 3, -5, -2. Z is at -4, 0, and L is at 0, -3. Okay, so now I'm using my rule right here. So I get this guy is at 2, -5. Okay, so that's the 90-degree rotation. Now we are reflecting over the x-axis. Now, if you're more of a visual person and you just wanted to reflect them over, you could. I'm going to be using the points over here. Let's use a different color. Okay, so the rule, x stays the same, y changes sign. And then there's your final image. okay. So now I'm going to have you practice it more on your own if you're not already there. I'm going to have you finish this page. So go ahead and work through this, and periodically I'll just put the answers up on the screen so you can check yourself. So I'm going to pause it here for my recording as well. Okay, so here is B, so you can check yourself. Here is C and D. Okay, and then you'll just do your homework on Schoology.